I get it now. The acid gives up the proton. That's just like Dr. Samide said in lab. That molecule that gave up the proton is the acid. Every acid gives up a proton. I finally get it.
Alan, actually, you don't finally get it. You see, not all acids give up protons. Do not let this concept, the half-truth taught to you by the chemistry department here at Butler. See, there are types of acids called Lewis acids, and they also have Lewis bases, like you have your Bronsted-Lowry acids and Bronsted-Lowry bases. See, the Bronsted-Lowry acids that you're thinking of give up the proton. Bronsted-Lowry bases accept the proton. What I'm going to teach you today is about Lewis acids, so have a seat. You see, the Lewis acid is an electron pair acceptor. Lewis base is an electron pair donator. The product of a Lewis acid Lewis base reaction is called the adduct, and the bond formed between the two is a coordinate covalent bond. Let me show you an example. So, for example, take a lead ion, and we'll add that to an iodide ion. And this will be our Lewis acid, and this will be our Lewis base. This reaction will form a molecule that looks like this. It'll be a lead poured into an iodide with lone pairs here still. And this overall molecule will have a +1 charge because we're just going to have the charges for these. Not all Lewis acid Lewis bases are like this here. There are several examples, but for this particular example, we have the product here. Remember, this is your adduct, the whole product, and this bond formed here will be the coordinate covalent bond. Some examples of other Lewis acids I will show on here. You're going to have your metal cations like lead. Also, you're going to have molecules, planar molecules, such as boron trifluoride, BF3. Another example is going to be your carbocations. Lewis bases, on the other hand, are going to be molecules that have electron pairs that donate. Molecules like this, for example, a good example is ammonia. Make sure he's got the lone pair right here to be able to donate. Diethyl ether is another good example. If you want to draw that out, it's right here. Here's your, this actually has 2 lone pairs to donate, but let's donate 1, be happy. And there's just more examples. Now we'll go into another reaction. This is one we talked about in class. And this is a reaction of Lewis acid Lewis bases that you will encounter if you are, for example, using EDTA to complex cobalt ions. And if you decide to run this reaction at a buffered system of between 9 and 10, you use ammonia as your buffer, you will have the ammonia reacting as a Lewis base, and you'll have your cobalt acting as the Lewis acid. What you can have here is you have your cobalt ion here, CO2+. Now the EDTA will react with it. Also, the ammonia will react with it. And basically, you can just have your cobalt. And what you can get up to 6 ammonias reacting with this. So, first one reacts, you get your NH3 here. And this molecule is still a Lewis acid. You can come one right here. Still Lewis acid. You can have one going up, you can have one going down. You can have, I guess technically, I'll draw these on a wedge here, and these will be on the dash. There you go, wedge right there. So as you can see, you can get up to 6 ammonias on this cobalt ion. So basically cobalt ion, cobalt with 1 ammonia, all the way up through 5, that's still a Lewis acid. Once it gets 6 ammonias complexed onto this molecule, however, you will no longer be acting as a Lewis acid because the cobalt can no longer complex another ammonia. So at this point it would not be a Lewis acid. However, up until that point, cobalt with any amount of ammonias on it would be a Lewis acid. Okay, I'm going to give you one more example of Lewis acids and Lewis bases. Let me erase this first. One more example is one we all encountered in organic chemistry last semester with our carbocations. So if you have a carbocation, I'll draw one here with a lot of resonance structures. Right here. Actually, you know what? I'm going to do one like this. That way there's no hydrogen, so I'm not drawing, don't have to worry about. And basically this here is a Lewis acid that can react with a Lewis base. Basically it is a nucleophile, and this is something we did in organic chemistry a lot last year. So, for example, if you have ammonia in the system, like we saw with our previous example, ammonia here has got the lone pair of electrons. This lone pair can serve as a lone pair that can be donated to the Lewis acid that can accept it. What you're going to have here is this molecule formed. And that would be this product here. Like as I said earlier, the product of a Lewis acid Lewis base would be an adduct. And this would be a coordinate covalent bond formed here. And that is Lewis acid Lewis bases.